So let's talk a little bit about simulation accuracy. So there's some known simulation limitations, like what I just mentioned, is that a whole part of the system is actually not included in the simulation. For software, in our case, the memory model wasn't accurate. So yeah, whenever we do this in another iteration, we'll make sure that check that first, I guess. What is included is, of course, data-dependent power consumption, delays, capacitance information, and any glitches that happen during the execution. But really what we confirmed, and I'll show that in the next slide, is that a lot of this detail is actually not necessary for side channel modeling. All of this leakage here, again, even though it doesn't look like the picture I showed before, like this, it is all happening in the right clock cycle. And if I know the clock cycle, I can still root cause it. So that's what we're actually seeing in this slide. So in the top is pre-silicon, the bottom is post-silicon. And what you're seeing here is the correlation with 16 intermediate bytes. Now, this is a 4S-box design, so we see 4 clock cycles of leakage. And in the bottom, we see that exactly those 4 clock cycles are also indicated. Again, we see differences in terms of amplitude here. Again, we don't care about that as long as we have an indication of the right cycle, we can go back to the root cause. What you'll also notice is the timing. It is accurate per clock cycle. Our triggers weren't exactly the same post and pre-silicon, so there's some timing offset here that we needed to correct for. But once we slide them on top of each other, we see exactly the right things pop up there.